Hello everyone, and welcome to the IWE Short Talk series on YouTube. My name is Bert Heinrichs. I'm a professor for ethics and applied ethics here at the University of Bonn. In this talk, I will present some thoughts that Charles Rathkopf and I have put forward on the ethics of AI. A more detailed version was published last year in Cambridge Quarterly of Healthcare Ethics. For those who want to look it up, I will provide the reference at the end of the talk. In my talk, I will focus on the concept of trustworthiness, which is widely used in AI ethics for some time now. There is no doubt that this is intended to address an important goal in the development of AI. Nevertheless, Charles and I believe that trustworthiness is not an appropriate concept. To be sure, we are not simply concerned with the word. Rather, we believe that the concept of trustworthiness is misleading, because it obscures an important difference between humans and machines. If we are right about this, then we should better not try to build trustworthy AI. Instead, we need to understand that AI can make strange errors that are incompatible with trust. For this reason, we have to find other ways of dealing with AI. My presentation is divided into 4 sections. First, I will explain that the term trustworthiness can be understood in different ways and that some common interpretations simply do not work for AI. Next, I will introduce the concept of strange error and explain why it is important for our understanding of AI. Subsequently, I shall offer some reflections on the ethical use of AI, where the concept of responsibility plays a central role. And in the conclusion, I will briefly summarize some of the key arguments. So, let's start. Trustworthiness. As I said, we think that the common concept of trustworthy AI is misleading. Why is this so? To answer this question, we need to take a closer look at the concept of trustworthiness and consider what it might exactly mean. Imagine someone lends you their car and says, "I trust you to give it back to me in one piece." According to a common understanding, the person is not simply estimating the probability that you will return the car undamaged. The person is also expressing the belief that you want to return the car undamaged. This understanding implies that trustworthiness is linked to certain motivational attitudes. If this is correct, the question of whether AI is trustworthy is not compelling. Hardly anyone thinks that present-day AI has the capacity for such motivational attitudes. According to an alternative analysis, the distinctive feature of trust manifests itself in the effect that it has on the parties involved in relations of trust. On this view, relations of trust are characterized by cooperation-supporting feedback loops. When you trust someone, that person becomes more willing to trust you in return. However, if trust requires this kind of reciprocity, then the question of which sorts of AI can be trusted is, once again, uncompelling. Present-day AI systems are not capable of trusting a human in any interesting sense, and are certainly not capable of learning to adjust the degree of trust in light of experience. Consequently, there can be no feedback-sustaining mechanism in the case of human relationships with AI. These observations give us some reason to suspect that debates about trust in AI are uncritically anthropomorphic, as several authors have recently warned. In other words, a concept that describes human interaction is simply transferred to the dealing with AI. However, there's another approach to understanding trustworthiness that may not make this mistake. According to this view, trust is an unconditional attitude. This refers to the following. When we trust a person, we adopt the policy that confirming what they say is unnecessary. We do not need to waste cognitive effort on convincing ourselves that the person is speaking the truth. Now, when we trust an artifact, we do something similar. We rely on the artifact but waste no effort on verifying that it is doing what it should. Regarding some types of artifacts, such an attitude is perfectly fine. When it comes to AI, however, our goal should not be to build a relationship with AI systems in which we can simply ignore what they do. It is now widely appreciated that the use of some such systems can reinforce pre-existing social biases. It would therefore be misguided to adopt an uncritical attitude towards them. One could try yet another approach. According to this view, the term trustworthiness denotes a purely epistemic phenomenon, something close to reliability. Let's think about whether this helps. Roughly speaking, reliability is a measure of how often something goes right or wrong. In the case of AI, or to be more precise, some forms of AI, it is a measure of how often a classification is correct. Of course, reliability is a valuable property of any AI, but there is still a problem. And this brings me to the second section of my talk, strange errors. To see why an understanding of trustworthiness as reliability is misguided when it comes to AI, an argument by the late Paul Humphreys is instructive. Humphreys was interested in the predictive failures of deep neural networks. If you give such an AI a picture of, say, a cat, it will output the label cat, along with a probability that describes its confidence in that prediction. It will also describe probability to all the other labels on which it was trained. Contemporary AIs can perform such classification tasks very well. However, they are also susceptible to adversarial attacks. An adversarial attack is a carefully engineered intervention on the input data that delivers a new image that looks nearly identical to the original, but which forces the AI to make substantial classification errors. Perhaps the most famous example of such an error was originally published in a paper by Ian Goodfellow in 2014. The example shows a photograph of what is obviously a panda bear, which, after having been adversely manipulated, is classified as a gibbon with 99% probability. In his argument, Humphreys offered a hypothetical example in which a person makes a similar error. A human called Roger appears at first to be an extremely reliable image classifier. Occasionally, however, Roger makes a strange error. Say, when shown a picture of a cat, he labels the picture as an elephant. Humphreys suggests that this kind of error would undermine our previous confidence in Roger altogether. Likewise, when an AI makes an error of that sort, we ought to lose confidence in it too. The fact that adversarial attacks are possible shows that AI can make such errors. And what's more, AI is not only vulnerable to such errors when they are intentionally induced, but they can also make them by accident. The point that Humphreys' thought experiment illustrates is that there is an important difference between humans and AI. Cognitively normal humans do not make mistakes of the sort Roger is described as having made. If they did, we would suspect that they suffer from a neurological disorder. To be sure, we humans make many kinds of errors and we make them frequently, but we share a cognitive background with other humans that is missing in the case of AI models. Therefore, the kinds of errors that humans make under normal conditions are not as alien as the cat-elephant confusion. By the same token, this means, if such strange errors are possible, referring to reliability alone is not sufficient. If we understand trustworthiness simply as reliability, we fall into a subtle form of anthropomorphism. We wrongly assume that AI does not make strange errors. To conclude, depending on which notion of trust one has in mind, the the goal of trustworthy AI is either dangerous because it pushes us to adopt an unquestioned attitude, or it is incoherent because it rests on one of two anthropocentrically biased assumptions. The crucial question now is, what conclusions should we draw from this for the use of AI? And with that, I come to the next section of my talk, responsibility. Let us first consider if there is anything we can do to defend AI against the risk of strange errors. Cameron Buckner argues that in order to understand adversarial attacks, we need a theory of artifacts in deep learning. If we had a theory about the patterns in input data that tend to generate strange errors, we could work to anticipate particular kinds of strange errors and thereby mitigate associated risks. So far, however, there does not seem to be a general solution to this problem. If this is true, what does this mean for a responsible use of AI? According to a widespread understanding, you can only be held responsible for things that you can control, at least in principle. If we cannot anticipate the errors that AI makes, does this imply that we must completely abandon the concept of responsibility? This view has actually been advocated by the so-called fatalist camp in discussions about responsibility gaps generated by AI technology. However, there are at least two reasons to look for a more refined position. First, not all errors are strange. Even if an AI is somewhat epistemically opaque, we can still study its behavior and look out for worrisome patterns. If our error analysis is not thorough, we bear some responsibility for whatever non-strange errors that occur. Second, even if we cannot predict strange errors, we can still say something about them. Above all, we can take into account that they do exist. For these reasons, it's unwise to make any bold claims about responsibility in the domain of AI. Nevertheless, there is no denying that AI in general, and strange errors in particular, make it rather difficult to say who is responsible for what. On top of the fact that strange errors make it practically impossible to anticipate the nature and magnitude of error, it is also the case that AI models are not constructed by a single person. AI is therefore susceptible to the so-called many hands problem. According to this problem, responsibility cannot be pinned to any particular person. Given the combination of strange errors and the many hands problem, it might be wise to explore options for restitution that do not depend on identifying a responsible party. However, this should be done in parallel to traditional attempts to assess responsibility. Strange errors make responsibility assessment more complex and less certain, but cannot undermine it altogether. And this already brings me to the conclusion, to the last part of my talk. So let's wrap up. I have argued that trustworthy AI is not the best concept around which to organize our efforts to develop an ethics for AI. Even when interpreted as a purely epistemic concept, the goal of constructing trustworthy AI is subject to a subtle form of anthropocentrism. It is practically impossible to anticipate strange error. This fact puts considerable pressure on our standard practices of assessing moral responsibility. If we want to exploit the benefits of AI, we will have to learn to live with strange error. Moreover, we must develop appropriate forms of restitution. Well, thanks for watching. On the slide, you can find the reference to the full paper by Charles and me in Cambridge Quarterly of Healthcare Ethic. I hope you enjoyed the talk. If so, please give us a thumbs up and subscribe to our channel.